Hello everyone, my name is Ali and today we'll be talking about migration in genetic terms. If you enjoy this video or any of the videos that are present on this channel, feel free to like and subscribe down below. Let's start talking about migration and maybe dive into a little bit more details. Migration in genetic terms is equally referred to as gene flow, and it has two major effects. First of all, it is going to be introducing and spreading unique alleles to new populations. That's number one. Now, if the allele frequencies of migrants and recipient populations differ, this gene flow will lead to alterations of the frequencies of the recipient populations, and this might seem quite complicated or difficult to understand, and we are going to be explaining that in details in experiments very soon. Now, in order to calculate the frequency of a certain allele after alteration, that means after the migrant population has entered the recipient population and breeded, by a gene flow, we use the following. The frequency of A, which is the frequency of the allele at hand, is equal to M, which is the proportion of the migrants. Px is referring to the frequency of the alleles or the allele at hand in migrants. So it is the proportion of migrants multiplied by the frequency of the alleles and migrants. That is obviously a value between 0 and 1. Plus 1 minus M, which is, let's remember that M is going to be referring to the proportion of migrants. However, I'd like to emphasize that this is the proportion of migrants. So if, for example, we've got 20 people that are migrating into a population of 80 people, that means 20 out of 100 are migrants. Therefore, the proportion is going to be 0.2. This is going to be present in the example that is going to be explained in details further in this video. Now, Py is going to be referring to the frequency of the alleles in the recipient population, and let's start explaining the example at hand. Now, the example says that the frequency of the allele is in the migrants is 0.6 and the frequency of the allele in recipients is 0.4. Now, there are 20 migrants that are moving to a population of 80 recipients. Now, let's simply plug in our values. We've got Fa, or the frequency of the allele, is equal to 0.2, referring to the M, multiplying Px, which is 0.6, plus 1 minus 0.2, which is referring back again to the migrant proportion, 1 minus 0.2, multiplied by 0.4, which is Py. This is going to be giving us the answer 0.44. So this is going to be the frequency of a particular allele after the migrants have entered and breeded with the after one generation, by the way, after the migrants have breeded with the recipient population. Therefore, the new frequency of Y is referred to as P prime Y, and in this case is 0.44. Let's try to dive into more details and let's see how we can calculate the change in allele frequency, and this is going to be referred to as delta P. We either use the formula delta P is equal to P prime Y minus Py. We figured out what P prime Y, which is 0.44, minus Py, which is 0.4. Therefore, we'll get the delta P, the change in the allele frequency, as 0.04. Or we can use the formula delta P is equal to M, all multiplied by Px minus Py, and if we use the previously given numbers, delta P is equal to, using the second example here, we've got 0.2 multiplied by 0.6 minus 0.4, so it's 0.2 multiplied by 0.2, giving us 0.04. Now, here it is worth noting that by substitution, we can easily calculate P prime Y. Like, we couldn't, from the beginning, we could have either not done the previous example that we mentioned in the previous slide and first done this, like we could have gotten the change in allele frequency and then calculated the new frequency in the recipient population. Let me repeat it. It's quite difficult. However, it gets quite easy when you with practice. So what I'm trying to say here is that, first of all, we have a migrant population that is moving to a recipient population. Allele frequency in X is different than the allele frequency in Y. So when they breed, when these migrants enter into the new population, what is happening is that the allele frequency of a particular allele, we're going to be referring to as X here, is going to be changing. So what we can do is calculate the change in the allele frequency using the formula delta P is equal to M multiplied by Px minus Py, since we have all the values here. Or we can, and then we can get the new frequency of the allele, or we can do the other way that we mentioned previously, which is get the frequency of the new allele P prime Y and then get the delta P. Both work and both are easy.